All right, we're taking a look at Angular today. This is Answer Everywhere. This is a live show, and it's an improvised show. Every episode, we're taking a look at a source code repository we haven't seen before, and exploring it, digging into it, um, kind of like finding our way in the wilderness. So today we're doing two today, which is unusual for us. We're looking at Angular now, and then after about an hour of Angular, we're going to look at Vue.js. I don't really do JavaScript. I've done just the tiniest bit of JavaScript. Um, I'm a backend dude. So I'm not sure I'm going to appreciate all of the finer points of what Angular is up to, but we'll see what we see. And I guess it's actually mostly TypeScript with some HTML, Starlark, maybe for build files, CSS, whatever SCSS is, presumably some variant of CSS. Hello, struct and shebang. Thanks. I'm good. Hope you're all well today. I've got I scheduled a pretty heavy workload of these this week, but also my one of my one of my kids is again home sick from school, so we'll see. Hopefully, I don't get sick and have to cancel, but we'll see how it goes. Um, all right, so there's a bunch of dot stuff, which should all be essentially metadata or configuration. Um, all right, cool. Well, good luck on your exam. Hopefully, it's not too difficult. I see some stuff here, ADEV, AIO. I'm guessing these are not essential, but I will open them. Dev tools might be interesting. Goldens, I'm going to guess, is like golden test resources, maybe like golden images. Modules might be important. That might be fundamental. Docs, I'll ignore. Packages is kind of on the same. Packages and modules are often synonyms for each other, but I assume they are not nearly the same thing in JavaScript. And then tools. I think I can mostly ignore tools, but we'll see. I'll take a quick look at this README to see if there's anything super informative about where the coolest stuff is. And I don't see it. So here's ADEV. And we see things like Firebase config. Where'd that go? Firebase and angular.json. Let's look at angular.json just to see what's up. This looks like maybe dependencies. These look like, although maybe this is a build file. Maybe this is like a JSONized build file. I don't know. We do have a Bazel build file, which tells us the application files are angular.json, TypeScript config.json, sorry, .app.json, and tsconfig, other more JSON-y stuff. And we're globbing all of the source files and excluding some generated stuff. And I guess until the whole project is built by Bazel, seems to suggest that they're in the progress of migrating to a Bazel build, a Bazel-based build from whatever the previous build was, which is nice. Maybe the previous stuff was built on npm. We have a lot of npm stuff, dependencies, and we have an architect test. I don't know if architect is the name of a test framework or a test package or something. And then we have pre-render examples, which I will ignore in source. And source has like a favicon and an index. So maybe this is the main starting point. We have main.ts and content and assets, which I'm guessing are like static content. Although content doesn't look very static. We have API examples, best practices, ecosystem examples. So maybe this isn't the entry point. Maybe ADEV is a folder of like examples and like starter packet stuff. Let's take a look at main.ts. It's tiny. Figure out why this is needed below. They're importing the Angular compiler. They're calling this bootstrap application function, passing in an app component in an app config, and they're pulling it from this app directory rooted at adev source, it looks like, and possibly logging an error. What is index.html? This logic must execute early so that we set the necessary CSS classes to the document node and avoid unstyled content from appearing on the page. Okay, so first it loads some theme stuff, and that's when you load a page, sometimes, especially in a slow connection, sometimes stuff loads before on some like clients' machines. It might load faster than it might. You might see stuff you don't see if you have a really fast machine, for example. So this is to prevent kind of like flickering of ugly, unformatted text and stuff, I guess. And we've got a Twitter description, a Twitter card, and this kind of looks like a demo app. So this is, click on my Facebook page maybe. So I'm going to maybe ignore adev. Here's AIO, which again, I don't know. Oh, this is useful. Angular documentation project, angular.ai, angular.io. So I guess maybe angular.com is the angular.com, vector-driven graphic design and material implementation. So whoever owns angular.com has, I guess we know here, Barbara Wickenden, they have turned down presumably lucrative offers from Google to buy the .com domain. So the documentation is at IO. Is this the main entry point for the project? Yeah, I think so. Okay. That's what's in that folder. That's not so interesting to us. Modules. Modules, we don't have much. We have a playground, which I don't think is going to be fundamental to understanding Angular. We have benchmarks, which again, I think is not fundamental. And then empty and a JSON config. And I think this is probably just literally type definitions. If I remember the 2 minutes I spent with what's it called? TypeScript. Okay, so here's packages. And in packages, we have animations, Bazel. I don't know why Bazel gets its own package. Bench press, common, compiler, CLI, compiler, core, elements, examples, forms. This looks like the main place to be. So where do we want to give it dig in? So goog.d.ts is presumably types defined by Google. 1 second here. Whatever. Is this interesting? We've got some Goog namespace with some placeholder stuff and things like get message, locale, debug. That doesn't look so important. Angular. The sources for the package are in the main Angular repo. Isn't that where we are? Sources for this package. Please file issues, etc. Okay, so let's take a look at router. That's presumably going to declare how you, when you go to some URL, it's going to tell you which like file, TypeScript file or whatever, or Angular component is going to handle, be the handler for that URL essentially. Service worker, that might be interesting, but it's probably not super fundamental. That might be slightly more advanced. Platform browser, I guess let's look at those. Testing will ignore. Localize and language service, I guess we'll ignore. Forms, sure. Elements is maybe the, usually with these frameworks, there's a massive collection of like Lego building blocks. I'm going to guess that's where elements are. That's what elements is, I mean. So we have some compiler, common, who knows. Animations might be fun, although this is going to be a relatively short stream. So let's look at maybe core first. Where did I put it? And then after core, let's do, we do router or elements. Where's platform server? Or platform browser. I'm going to guess those are not so cool. Maybe forms can go higher up. Compiler is probably after core. Here's application init. This is the thing that starts it. So we have some dependency injection stuff. We get a DI token. The token is somehow, I guess, used to redeem with a dependency. The provided functions are injected at application startup and executed during app initialization. Okay, so at startup, they somehow go into some constructor essentially, and then when you initialize, the functions get executed. So they're like things things you want to run at startup. If any of them returns a promise or an observable, initialization does not complete until the promise is resolved or the observable is completed. For example, a factory function that loads language data or an external configuration. But this is all like a code comment, right? So where's the actual code that does this? So we have this app initializer, which is going to be set to a new injection token of a read-only array. I guess this is the type, right? So it's a read-only array it's like a parameterized type that sends the unit type to an observable of unknown. It's either something that's going to produce an unknown observable, maybe like an any type observable of any type, essentially, or an unknown promise or void, or like a function that does nothing, a function that has a promise, or a function that's an observable. And that's the app initializer. And then we have a class that reflects the state of running app initializer function. So this has this resolve stuff that's going to take take a list of any arguments and do nothing. I guess presumably it's going to resolve the promises. And we're keeping track of whether we are been initialized and whether we're done. And we have a done promise, which is whether we're done is going to be its own promise. And it's just going to, I guess, try to resolve all the stuff, or maybe reject all the stuff, perhaps. And then we have here, this is kind of similar to some stuff we saw in React. It's looking at the development mode. So like if it's undefined, which is maybe the default, then we'll do some stuff, or we're in dev mode. And then I guess production mode is going to behave differently. We have this run initializers function, and it's idempotent in the sense that if you've already initialized, we're going to do no extra work. We're not going to like rerun stuff. And presumably we're just going to iterate over stuff and call things. We're going to iterate over the app inits, which is some initialization stuff, call each of the app inits and get a result. And if it's a promise, we are going to push it onto our list of promises. If it's something you can subscribe to, we're going to make it into a promise. So in this sense, I guess like subscribable and maybe observable are just not quite syntactic sugar, but the real stuff is promises, and observables are like, I guess, implemented, thought of as promises. It seems to be what is going on. So like they're promisifying and doing a subscribe here. I guess they're promisifying this subscription. And then they're pushing these observables as promises onto the init promises. And the complete function is something you can call to say that we're done. So it sets done to true, and then whatever resolve is doing. And then when we're done here, I'm not sure. Maybe this is part of, I don't know, just syntactically, but at some point, we're taking all the promises, all the async init promises, which I think is what we populated up here. Yeah. And then we're trying to complete them. So this is, I guess, the code that runs the promises. So that's how application initialization is done. Let's look quickly at create application. Internal create application is presumably the real function. It creates an application API that implements the core application creation logic and optional bootstrap logics. Platforms such as platform browser. So I guess platform browser is the idea, I guess, is you can run Angular apps on different platforms, and platform browser is presumably the web browser, probably mostly Chrome. And we have a root components. So we have some sort of tree, and we have app providers. Whatever an app provider is, I guess it's something that you use to provide the app, like provide a browser, perhaps. And sorry, that would be platform provider. App provider is maybe something you implement. And we try to get this from the config. And we might do some asserts, I guess, if we were in dev mode. And then we have this platform injector, which is like this dependency injection stuff. And this is all just kind of set up, which I guess let's ignore and move along. So compiler, I thought would be really interesting, but there's like these two files here: compiler facade. You can get a compiler. Well, or what do we implement with? Importing. The JIT compiler. Maybe the compiler is just the like the V8 JavaScript compiler essentially. We have this thing JIT compiler usage, which is maybe for metrics. JIT compiler facade is doing what? We've got some global ng. I don't know what that is. And JIT compilation failed. So this is just doing just in time compiling, I guess. Hydration. Let's look at hydration. Hydration. Okay, so this would be the thing that populates views, I assume, is what hydration is about. Given a current DOM node and a serialized information and serialized information about the views in a container, walks over the DOM structure, collecting the list of dehydrated views. Okay, so just in the interest of time, I'm going to just assume that this is doing what it says. It's going to get all the dehydrated views, and then some other function is going to hydrate them, I guess. Find matching dehydrated view impl. Retrieves the next dehydrated view from the L container and verifies that it matches the given template ID from the T view that was used to create this instance of a view. So we have some template. We have a dehydrated view, and we're somehow going to guess take the template and populate it for putting in the view or something like that. And we're checking if the IDs match so that we're not doing the wrong thing. Thus, all dehydrated views from this L container are removed. Okay. This is going to find the implementation just by looking at the ID, essentially doing a for loop. I'm looking at AD. But where do we actually hydrate? This is maybe just a file for working with views. Tokens, API, maybe let's look at API. Indicates whether the hydration related code was added. Application is stable. So this is like, I guess, an API that you can use to, if you decide to use, maybe hydration is optional. Disable hydration. And this seems to be stuff for like turning on and off hydration or something. It's the process that restores the server-side rendered application on the client. This includes things like reusing the server rendered DOM structures, persisting the application state, transferring application data that was retrieved already by the server, and other processes. Hydration improves application performance by avoiding extra work to recreate DOM nodes. Okay, so without hydration enabled, server-side rendered Angular applications will destroy and re-render the application's DOM, which may result in a visible UI flicker. Okay, so this seems to be more of an optimization than something fundamental. So I'm going to move along. Here's DI, and we see injector, consistent with our theory that this is dependency injection. Let's look at injector.ts. Hey, somebody's saying, tired after day, but still here. I'm glad you're still here. All right. Okie doke. Injector. Concrete injectors implement this interface. Injectors are configured with providers that associate dependencies of various types with injection tokens. Okay, so what are we actually doing? We have some abstract injector class that it's got this provider token. So get, you're going to, I guess, give it a token, which is a provider token of something, maybe a provider token of some like element, and what to do if, I guess, the thing is not found, and possibly some options. And it's going to return a T, so it's a getter for this T thing that you were trying to provide. It retrieves an instance from the injector based on the provided token. So given this API, I think this is going to be pretty simple because um, if you just have a thing that you can call get on, then then the maybe the hard part of the injection is code that we kind of glanced at but didn't really dig into, which is like as you are initializing the application, just making sure the things that are holding your dependencies are where they need to be when your application starts running, I think. So let's take a quick look at create. Create, we'll take some options and some providers, including a parent. So there might be some tree structure to the injector, I suppose. And if the options is an array, we're going to call this version of create injector. Otherwise, we're going to look at the options name. I guess if it's not an array, it might be a single option, so it has a name. And we create an injector with a name, whereas before we were creating an injector with the empty name and the empty whatever this was. I guess name gets passed here again. But this is like maybe a dict containing the name. I don't know what this notation is in JavaScript. I don't think it's templating. I think it's maybe just the like a object notation. Okay, so that's injector. I'm not going to look too much more at injector. Util, I'm going to definitely ignore. View doesn't seem to have much. Zone, what is ng? I guess ng stands for Angular. Ng zone, an injectable service for executing work inside or outside of the Angular zone. The most common use of this service is to optimize performance when starting a work consisting of one or more asynchronous tasks that don't require UI update. So this is like running stuff in the background. Such tasks can be kicked off via run outside Angular, and if needed, these tasks can re-enter the Angular zone via run. Okay, that's not so, I think not so fundamental. This is event emitter. It's presumably going to emit some events. How are we going to do that? I'm not sure. Using the components of the output directive to emit custom events synchronously or asynchronously and register handlers for those events by subscribing to an instance. So this might be important, but we've seen, I think, a bunch of implementations of this sort of pattern. Should we look at subscribe? Maybe look at subscribe. Returns a subscription object. And we're getting the next function, I guess, or sorry, we're assigning the next function to the first thing that's passed in, which is essentially an any type. And then there's keeping track of error, and I guess that there's like a completion callback. And then if we have an observer and its type is an object, then I guess we cast the unknown as a partial observer and set next function, etc. And then we call super subscribe. So whatever the thing we're extending, and we're just setting these things. And so subscribe is presumably going to keep a list of everyone that needs to be notified and notify them when the event occurs. Linker seems to be compiler stuff. I'd like to know more about how the compiler works, but I don't think I'm really going to get there in the time I have. Pending tasks. This is presumably task management stuff. Internal service that keeps track of pending tasks happening in the system. This information is needed to make sure that the serialization on the server is delayed until all tasks in the queue are completed. Pending tasks continue to contribute to the stableness of application ref throughout the lifetime of the application. Okay, so this is just task management. Then zone, I guess we saw some zoney stuff. So we have, what have we not really looked at? We have compiler, which this is the folder I was expecting to see. So we have a JIT compiler. We can inject some stuff. Should we look at the core? View encapsulation, emulated, none, or shadow DOM. I guess historically the value was 1 was for native encapsulation, which has been removed as of V11. Okay, essentially, seems like shadow DOM is what we're using. We have a change threat detection strategy, which I guess we can say that things have changed if something has been pushed or whatever default is. Input. I'm not sure what this is, but we have like, is it a signal? Some transform, I guess, that can be applied to it. Is it required? Is there an alias for it? Input flags, host binding, security context, inject flags. All right, so we have a parser, so this is starting to look more like a compiler. And among the things we can parse are a CSS selector. So we're going to parse, I guess, CSS, selector class names, etc. And we're going to do what? Store them in a list or something. And then we're going to get the element names from the selector. And we're going to return this list of stuff, which is an R3 CSS selector. I'm not sure what R3 is, but we've seen it a bunch of times. So maybe it's like the version Angular 3 or something. So this stuff I think is mainly about you're giving it some CSS and it's translating it into, it's starting to translate it into things that Angular can reason about. Render flags, whether to run the creation block, e.g. create elements and directives, or to update. Okay, so I guess that's like live update versus creating from scratch or something along those lines. Attribute markers, etc. So this is kind of like setting up the compiler. Do we have any functions? No real functions. Render 3. We have an AST. This is the abstract syntax tree, and it's got things like everything's going to implement a node. It's a tree, so these are, I guess, the tree nodes. And we should have a node for all of the interesting maybe tags in the HTML. Comment. I don't know if comment is an HTML tag, but text and bound text. So these are not maybe lining up with tags, but some I guess like Angular elements. And we're building up a tree. And I think that's about all I'm going to glean from this in the few minutes I have left. And we have this just-in-time compiler. Let's see if there's a control flow. Control flow might be interesting. Create if block. Creates an if block, an if loop block from an HTML AST node. Okay. An if block of what? I'm guessing like it's creating JavaScript. It's compiling to JavaScript maybe. New T if block. Or rather, maybe the target is the whatever the language that V8 uses. So take a look at the Angular. You know what? We should also give me an overview of the Angular compiler. And we'll come back to that in a second. I guess we might as well open this. Oh, that's not going to be so helpful. Here's the router. Again, we don't have a lot of time, but let's see if there's anything. Let's look at router.ts. Exact match options. So I guess this is like, what are we matching? Paths or a fragment or matrix params? I don't know what matrix params is. Maybe a way of putting parameters in like a list of more than one dimension. We can get, so subset match options. These are options, I guess, for things that match as a subset. And then a router has a current URL tree. Maybe that's a tree that you provide, that you give it the structure of where all the things are, and the router is using this maybe as a reference to decide where to go. A raw URL tree, whether I guess we've been disposed, whether the ng zone is enabled, some console stuff, a state manager, and this is all we're calling inject. So this is the inject function, I guess, that where the wiring happens like on app creation. So this is kind of just setting stuff up. URL serializer. We have a list of events. Is used internally to push events to it, et cetera, et cetera. Okay, and then router state, which is going to return this state manager get router state. And then a handler for navigation errors. So this is some error handler. Navigated is a Boolean that's true if at least one navigation event has occurred, false otherwise. I don't know what this means, has occurred in the history of running the app or recently, I'm not sure. A strategy for reusing routes. Route reuse strategy. I guess this was something configurable that is maybe no longer configurable, or you use providers instead. How to handle a navigation request to the current URL. So this is like if you're at, let's say, index.html and you navigate back to index, maybe what do you do or something like that. And here's some event subscription stuff. Subscribe to navigation events. So I guess you can subscribe to navigation events, but do you need to? This is like checking if various conditions hold and then calling the appropriate handle router event on the state manager. So maybe the state manager is the thing that actually handles the router. Reset root component initial navigation sets up the location change listener and performs the initial navigation. Navigate to sync with browser schedules a router navigation to synchronize router state with the browser state. This is done in response to a pop state event. Okay, this is, I guess, potentially interesting. This seems like something that's easy to mess up, synchronizing two states of routing. Seems like it's easy to mess up, but I don't think I have the time to really dig into it. Here's the create URL tree command. You give it some commands, some navigation extras, and some options. What are the commands? Oh, here's an example. So you give it like /team. That's the, a command is like a list, I guess. Is that what this is? This is a single argument. So team 33 user 11 creates the URL team /33 user 11. And then I guess if you want to pass in whatever these are, it's almost like a query parameter, but there's no question mark. Does it need to be a question mark? I'm not sure. But I guess you use this dictionary notation. All right, and that's going to build that up. Navigate by URL. Here's the function I was looking for, I guess. So you're going to give it a string or a URL tree and some extras. Or maybe the URL tree is just the parsed URL. Like a URL is like a path, right? So this is root, and then you go down the angular, you turn down the angular hallway, and then you turn down the angular hallway again. And you turn down the blob hallway, etc. So maybe by the path, it means like this a parsed URL or something. We're going to have this Boolean promise thing, and we're going to check what the development mode is. Are we developing or are we running in production essentially? And depending, there might be a warning. And the URL tree is indeed just a parsed URL, okay? And a merged tree is we're going to take the URL handling strategy and merge the URL tree with the raw URL tree. And that's going to somehow do some merging stuff. And then we're going to schedule navigation. And then schedule navigation is presumably just going to set a task essentially, or a signal. And then at some point, maybe navigate will be called. Navigate based on the provided array of commands and starting point. So navigate will take the commands, validate them, and then call navigate by URL. And is this the one we just looked at? Yeah. Okay. All right. That's enough for that nonsense. This is form builder stuff. I thought that might be interesting, but I think we're like totally out of time. So let's plow along. Platform browser, we're going to ignore platform server. I'm guessing these are different platforms in the sense that your Angular thing might run on the server, it might run on the browser. Elements is going to be, I hope, a collection of elements, but maybe not. There's like nothing here. Element strategy, index package. Pretty empty. Elements factory strategy, create custom element strategy. We're importing some stuff, injector ng zone, nothing that really looks like an element in the sense that I was thinking it would be. And then animations, which is probably fun, but we're going to ignore. And maybe common has a bunch of stuff like navigation pipes, common, DOM adapter. Somehow it's going to adapt DOM token. I don't know what that will be about. Viewport scroller. He's got some scrolling stuff. I guess let's take a look at these DOM stuff really quick. Cookies will presumably be support for storing data in cookies, getting cookies from the client, etc. Viewpoint scroller. Desugared tree shakeable injection. Okay. So we're checking whether we're a browser, etc. So we have this ability to set the top offset when scrolling to an anchor. We have get scroll position. These are all abstract. And then I guess here's the implementation. So get scroll position is going to call window scroll X, which I think is like provided by the browser. This dot window scroll to. So this is just maybe everything seems to be happening in the window. So where does window come from? Yeah. Okay. So I guess you're passing it in. So it seems to mainly be delegating to the browser, I suppose. So find anchor from document. So you're going to give it a document, and it's going to try to find, I guess, where the anchor points to. Get element ID and get elements by ID won't pierce through the shadow DOM. So we have to traverse the DOM manually and do the lookup through the shadow roots. Okay, so we're doing some DOM walking because these things won't go through the shadow DOM. And we haven't seen how the shadow DOM is implemented. But I don't think we're going to have time to. Is it in the DOM adapter? I doubt it. The DOM adapter needs Domino-friendly test utility. I guess Domino is maybe a testing framework. We can dispatch events, etc., etc. Let's do a quick look for Shadow DOM. Shadow DOM renderer in platform browser. Okay, makes sense that it's in platform browser, which I skipped. We'll take the quickest of looks. We've got an event manager, and presumably we're just going to keep a version of the tree and manipulate that, right? We're iterating over some styles. For style of styles, we're going to create element style, set style one to it, set its attribute to some nonce, I guess. I guess we're using the style only once. And setting the text style, and then shadow root append child style E1. This seems like that means that I guess you're passing in the shadow root. And I don't know if this is the root of a subtree or if this means that every style is directly a child of the root. I'm not sure. Node or shadow root. So node or shadow root, you give it a node and it checks whether it's host EL. And if it is, we're going to return the shadow root. Otherwise, we'll return the node or something. Is this EL or E1? Host element, I guess is what it means. All right, I'm not sure. We saw more of shadow root in, I think in React. We've seen a couple of these frameworks. My goal here is to kind of just give a flavor of how is this different from other stuff, and then let's see what Bart is saying about the compiler. The Angular compiler, bridge between dev experience and runtime performance. The Angular compiler, often referred to as NGC, plays a crucial role in transforming your Angular code into an efficient and optimized form for the browser. It compiles TypeScript code. Okay, that makes sense. So your browser can't run TypeScript, so it's built on the TypeScript compiler. It adds Angular-specific functionalities, like translating templates and decorators into executable JavaScript. You have templates and decorators, which are, I guess, ways of adding some declarative stuff that I guess can be like enlivened at runtime, like you are, like Pinocchio came alive or whatever. And we have got ahead of time and JIT versus JIT compilation. I know that they do JIT. They do AOT. And so it seems to be some amount of AOT that compiles during the build process, resulting in smaller bundle size, better performance, and improved security. I also saw something that said that um, Angular will detect more errors at runtime than something like Vue. So maybe that's true. It seems like if you have this compiler ability, then it should at least do type checking and catch type checking errors at compile time if it can, unless you're using lots of like any types, things that are only known at runtime. And then it converts its key functionality. So it converts HTML templates into executable code for DOM manipulation. Okay. HTML templates. I'm guessing, so HTML itself doesn't really transform into anything executable in a meaningful way. I'm guessing it's the templates that contain HTML and some kind of markup, code like markup that and this is the thing that gets turned into executable code. Processes component decorators and directives into JavaScript instructions. Okay. And optimizes code for smaller bundle sizes and provides build time, blah, blah, blah. And then performance, blah, blah, blah. So I'll say, so how does Angular's strategy here for performance differ from React's? Is it React? React is the framework, right? It's not just the like reactive programming thing. Yeah. They're both high performance, blah, blah, blah. So Angular focuses, I guess, on AOT compilation, which makes sense to me. I like things that are compiled, but I don't think that's I don't think that's the way that most front end stuff works. So maybe that feels a little bit awkward to front end people. I don't know. Let me know if you've used Angular. Does it have a reputation for being kind of like hard to use, like a large thing that's not very nimble? I think it's maybe the reputation I've gleaned from just kind of reading between the lines from what people talk about. Emphasizes tooling and build optimizations, but it makes sense for a place like Google, right? So Google has these web pages that need to perform very well, like say Gmail. I don't know if they use Angular still for any of the big household name products, but I assume at some point they did, or at least Angular was informed by what they were doing internally. Enforces a stricter structure. Angular's two-way data binding and structured approach can lead to more optimized code if followed correctly. So this is one thing. So the two-way, the React has like the one-way thing, which I think is easier to reason about. So React prioritizes flexibility and runtime performance. It focuses on the just-in-time approach. Okay, for easier development. This can lead to larger bundle sizes and potential performance drawbacks. Bard might be biased here since it's a Google thing. Optimizes virtual DOM. Helps minimize DOM manipulations. I guess that's not so important. If you're doing a lot of the DOM work at compile time, it's not so essential to have great real-time DOM performance. And usually if you have to do great like real-time performance to complete faster, you have to give up some optimality usually. So like, I think if you tell your compiler that you want optimized code, it will take longer to run all those optimizations. And I assume something is similar is true of the virtual DOM, and it relies on developer choices. So I guess you in Angular you have to follow like a structure more. Okay, all right. I think that's about all the time we have. I'm supposed to be starting my other stream, I think, right now, so I'm going to hop off here, and maybe I'll take a minute or two to have a sip of water, and then we'll look at Vue.js.